The synergy between the automated systems and human oversight guarantees the purity of the compounds.
This AGV transports the massive copper foil from the mixing deck to the coating hall, ensuring a seamless logistical flow in the battery production process. The slot die nozzle extrudes a micrometer-thin layer of cathode slurry onto the rapidly moving foil. The sheer scale of this 50-meter drying tunnel highlights the time and distance needed to transform the wet coating into a perfect matte finish. The heart of the assembly, the winding machine. Here, the anode, cathode, and separator are spun together at blinding speed into a perfect spiral.
A high-speed robotic wheel plunges the soft rolls into the steel casings. The motion is seamless.
The X-ray allows us to inspect the internal structure of the battery non-destructively. As the digital twin scrolls, the cells are moved to a hot room, or aging chamber, kept precisely at 45 degrees Celsius.
The robotic sorter manages manufacturing variants, splitting the stream of batteries into 5 distinct. This is the critical first step of aggregating power, where individual cells are rapidly organized into modules. This intricate copper and aluminum bus bar is precisely aligned over the cell array, preparing the module for the permanent electrical connection. The heavy payload robots precisely lower the 30-kilogram battery module, ensuring perfect contact with the cooling floor thermal paste.
This concludes the manufacturing journey.
The electric drive units are lifted into place. Robotic arms bolster the suspension components. A hard vacuum is pulled on the cooling loops. Then the glycol mix is injected under pressure to prevent airlocks.
Using the AI scanner in conjunction with the striped LEDs ensures a flawless finish. The goal is absolute perfection in the paintwork.
The motion of the trucks implies the global distribution of the product. This concludes the manufacturing journey.
The gram weight is exactly on target.
Good. That ensures the 20-year structural integrity.
Because prismatic cells have massive terminals, the welding lasers here are larger and more powerful. The camera filters down the brightness to show the thick copper bus bars.
These container-sized server racks are built to withstand the harshest environments, assembled by an array of precision welding robots.
A little lower now. Watch the alignment.
Looks good. Keep going down.
Even against hurricane conditions, the cabinet holds strong. A look inside confirms complete protection, verifying the IP67 rating. This urban mine is where we reclaim vital materials. Our AI sorts the incoming packs, distinguishing between NMC and LFP chemistries. Before shredding, the batteries must be drained. They are plugged into a discharge grid that sucks the remaining energy out and feeds it to the recycling plant's lights.
This substance is the gold of the recycling process.
As the acid is introduced, the metals dissolve into this green solution. Digital sensors monitor the pH.
The distinct separation of cobalt, visible as the bright blue layer, is a critical scientific step.
As the liquid evaporates, pure white lithium carbonate and bright blue cobalt sulfate crystals fall like snow into the collection hoppers.
The electron microscope confirms it. Recycled lithium is indistinguishable from the mined equivalent. The infinite loop is now a reality.
As we replace traditional graphite with these silicon nanostructures, we unlock the potential for vastly
Unlike the rolled cells, these solid-state prototypes are stacked flat. A robotic arm places alternating layers of cathode